Welcome to Part 2 of the Blue Gecko Module Wireless Starter Kit Temperature Sensor video series. In Part 1, we discussed the main project definition, hardware configuration, and GATT structure. In this part, we'll look at exactly how the BGScript implementation of the sensor works, and then the third video will wrap up by compiling, flashing, and testing the firmware. BGScript is a simple scripting language that lets you develop code right on the module without needing an external microcontroller or in-depth knowledge of C and the Bluetooth Smart Stack. It's kind of like BASIC, or kind of like Python, depending on what you're familiar with now, but in any case, the syntax is pretty easy to pick up and intuitive once you explore some example code. I'll go through the complete script in detail here. Keep in mind that there are two different documents you should have handy for BGScript reference. One is the BGScript Developer Guide, which covers the language structure and syntax, built-in operators and functions like if and memcopy, and variable types and declarations. The other is the BGM111 API Reference Guide, which contains details on every single API method that's currently part of the stack. It's good to keep both of these readily available whenever you're working with BGScript. BGScript is built on top of the BG API layer in our Bluetooth Smart software stack, and it's an event-driven language. Every part of the script that runs must first be triggered by an event that occurs within the API. Here, right under the list of user-defined variables, constants, and imports at the top of the script file, you can see the system boot event defined. Each event handler, like this one, starts with the event keyword, then the event name, followed by the list of parameters which you can get from the API reference guide. When the event is triggered, the BGScript interpreter executes every line of code in order until the end keyword is reached. Events are added by the API layer to an event queue for execution in the order that they're generated, and then they're executed atomically start to finish. One BGScript event handler can't interrupt another one. Apart from a few built-in operations in BGScript like direct variable assignments and if-then statements, most of the work in the application is usually accomplished with API commands that begin with the call keyword. Call is followed by the name of the command, then a list of parameters in parentheses. This first hardware configure GPIO command sets the PF6 pin to an output high state, so we can use it to control one of the LEDs on the evaluation board. The specific parameters here are 5 to specify port F, 0 is A, 1 is B, and so on, then 6 to specify pin 6 on port F, then this built-in hardware GPIO mode push-pull constant value, which is part of the API, to set output mode, and finally 1, which sets the output state to logic high. These parameters are documented in detail in the API reference guide section describing this command. Now that we've seen an example of an event handler and a command call, I want to jump down to a later part of the script for a moment to show an example of the last type of API transaction, which is called a response. Every command except system reset generates an immediate response to acknowledge that command, and in many cases provide some feedback, such as a result code or a bit of information that was requested. In BGScript, the response data is accessed by providing a second parameter list in parentheses after the first list used for the command call. Notice how this is done with this GATT server command. The retResult parameter is a user variable which the stack will use to store that value from the response. In this case, a result value will be 0 for success, or non-zero if the command failed. A list of error codes can be found in the API reference guide. You'll notice throughout the rest of the script content that most commands don't have this second set of parentheses. This is because BGScript allows you to ignore the response data if you don't need to use it, simply by omitting the second parameter list. This is safe to do as long as the response from any particular command doesn't change your application's behavior. Before we finish walking through this code, I want to point out one other BGScript feature that you can see back up at the very top, and that is the ability to import other BGScript source files. This is basically like including files in a C project, and allows you to create logically separate modules that keep your code organized and reusable across multiple projects. In this script, I've created a couple of custom procedures to handle I2C communication with the SI7021 sensor and to convert temperature data into a readable format. We'll look at these scripts briefly as we go through the rest of this one. Back to the system boot event. After the pf6 configuration command, we set the advertisement parameters to a reasonably fast 100 millisecond interval, then begin broadcasting connectable advertisement packets so that remote BLE devices can scan and connect. Finally, this hardware set soft timer call begins a repeating timer on a 1-second interval, which we'll use to read the current temperature. That's it for the system boot event. Next, the hardware soft timer event does a few different things each time it ticks every second, as we set above. First, we set pf6 low to turn on the active low LED wired to that pin using the hardware write GPIO command. Then we call a user-defined procedure to read the temperature value from the SI7021 sensor. Jumping over to the SI7021.bgs source file, you can see how this is done with just a few I2C peripheral calls to write a register address, read 2 data bytes back, and then stop the I2C transaction. Finally, the data read is switched from big endian byte ordering, which is how it arrives from the sensor, to little endian, which is how BGScript stores and manipulates multi-byte integer data. 2 important things to mention here are, first, that user-defined procedures cannot return values, either in a single return statement or in a second parameter list, the way API commands do. This is why the final result is stored in a variable at the end of the procedure, instead of being passed back somehow. While procedures do support parameters, they're always passed by value and can't be modified within the procedure itself. Second, note the use of the export keyword in front of the SI7021 data variable declaration and the procedure definition. Using export is necessary for any variables or procedures that you want to be available outside of this script file. Variables and procedures which are not exported are confined to the same file, a sort of local scope. Jumping back to the main script file now, once that procedure completes, the data is stored in the globally available SI7021 data variable, which is then converted into the format required by the thermometer service specification using BGScript's built-in float function. The 4-byte value returned from the float function is stored in the temp data buffer, completing the 5-byte full temperature report. This buffer is first passed to another user-defined procedure which outputs a readable ASCII representation of the temperature. Looking over at the prettytemp.bgs file where this procedure is defined, you can see a few calls to the endpoint send API command, used here for UART output, and many variable operations, conditional statements, and even a while loop to decode the temperature report. Details on exactly what is being decoded here can be found on the Bluetooth SIG's online definition page for the temperature measurement characteristic, available at developer.bluetooth.org. The procedure finishes up by sending the ASCII representation of the temperature out the specified endpoint using the endpoint send API command. Back to the main script, the next API call first pushes the temperature value to a remote GAT client if it has subscribed to indications, and then the event wraps up by turning the LED off again with another hardware write GPIO command. All of the code in this event handler occurs very quickly, so the LED only pulses on for a very short time. The last LE connection closed event detects a disconnection from a Bluetooth low energy client and tells the module to resume connectable advertising, which won't happen automatically otherwise. Alright, that's it for part 2 of the series. Make sure you finish up with the last video in the series to see how to compile, flash, and test the project. Thanks for watching.